So let's take, so we just described what covariance is, right? And I assume, or at least you got a little bit of a sense of what we're trying to do here. Let's split this data set we have uh, between years 1982, okay, more than 1982 to less than 93, right? 19 more between 1982 and 1993, right? And we are going to take the interest rates and the value of our portfolio invested in large US companies, right? And we're going to create a separate data set here, okay? And this is so let's X be a random variable to represent the interest rates on 10-year treasury bonds. Basically, treasury bonds are the type of investments where you lend money to federal government at for 10 years time frame, right? So basically you invest today and you collect interest every year, and at the end of 10 years, let's say you invest $1,000 today and you collect interest every year depending upon what the prevailing interest rate is when you locked in, when you bought those bonds. You're going to get that interest payment for 10 years, and that at the end of 10 years you're going to get your money back, that $1,000 back, right? That's basically lending money to US government, right? And let Y be the random variable representing the value of 1,000 invested in large company US stocks. Okay, so you have these two columns, right? uh, Interest rates, value of large company stocks, value of your portfolio in large company stock. So we can sort of see, right, as interest rates went down, right, from 10%, okay, imagine, to 7%, the value of your portfolio went up, right? That's not completely why it went up. That's not all. That's not why. That's not entirely as to why it went up. Of course, there are many other reasons why your portfolio value would go up, but interest rate could be a small factor, right? But what we are trying to sort of, so some of the times, okay, so that's a good segue into trying to sort of say that sometimes you can sort of fit the data to your theory, right? And that's what I'm doing. Okay, I'm fitting data. Okay, I'm seeing this. Oh, okay, so I'm fitting the data to the theory that because interest rates went down, the value of my portfolio went up, right? So that's not entirely true, but we're just trying to understand the math, okay? And and we can sort of see the inverse relationship, and we can sort of plot it, okay? And here we see that plot, okay? So as interest rates went down, okay, your portfolio value went up, right? We can sort of hand calculate as to what the covariance is, okay? And we can do the same. So this is exactly the same math between those two columns we did in this Excel spreadsheet, okay? So no different, okay? This is exactly the same thing we are doing. And we calculate this covariance of minus 33, okay? So that is an inverse correlationship, okay? So we see a negative sign depicting the inverse relationship, which is what we expected, okay, based on the plot we saw, okay. But apart from knowing the polarity, what else can we do with this number, right? Or what does it mean, okay? Not much for now, but let's try another time period between say 1973 to 1982, okay. And let's look at another data set, create another data set between 1973 and 1982, the same two random variables, which is interest rates and your portfolio value. And as you can see, during that time frame, okay, and you can see it conceptually here, okay, and there is a reason why I'm picking those two time frame, right? And you can see between those times the interest rates went up, and let's see what the value of your portfolio did during that time, okay, because it's not pretty evident because the scale is not a lot. So ideally you would want to look at this kind of growth in value. So this is more like a compound interest kind of a thing. So you might want to look at it in a log scale, okay, at least the y-axis, okay. But let's go back to that, okay. And depending upon when the course sort of progresses, depending upon how much are you interested in this kind of stuff, I can pull in more data from other avenues. So we'll talk about it, okay. But when we look at that data series, okay, when between 1973 and 1982, we see that there is a positive correlation, right? Basically what that tells you is that as interest rates went up, the value of my portfolio went up, okay. So I'm going to fit another theory saying that, hey, maybe a lot of the Okay, so what kind of companies? Okay, now so let's look at another angle. What kind of companies would sort of benefit from the fact that the interest rates are going up, and what kind of companies are going to make more money? Most of these companies will be financial type companies, right? Because they are in the business of lending money, right? So if they have lent money today, they are going to collect more and more interest income every year, right? So, and they are going to keep on lending money, and people will keep coming to them to deposit their savings, and they are going to. You and me, when we go to the bank, right? Uh, they will give us hardly any interest nowadays, right? Because the interest rates are almost close to zero, right? They will give us say 0.5%, and they then turn around and take our money and lend it out say at 4%, 5% for you to buy a home, right? So they make that markup, they make that differential, right? So the higher the interest rates are, the more people sort of flock to sort of deposit their savings into bank type companies. And if you are an owner of those companies through the stock market, you are likely to benefit from that interest rate environment, right? So that's one way to capitalize on that. But let's say that is the theory I'm putting out. Okay, again I'm trying to fit my theory to this data, right? And you see, doing the same math, you see there is a positive correlation, because that's what we are looking at, right? So a positive covariance was expected, and that is what we get. Okay, and of course a covariance of 0 means there apparently is no relationship between the two variables, right? But that requires a little bit of clarification, and we'll get to that in a bit. So we know how two variables are related, right? And what does a covariance of but then what does as I alluded to, what does a covariance of 7 means, or a covariance of 1.5 or 500 or 5000, right? So it's hard to sort of quantify the extent of this relationship, because the variables under considerations are two different units, right? Or two different units of measurements. For example, on one hand we are looking at interest rates, which are in percents, okay, and the portfolio value, which is in dollar terms, right? So you're comparing two different things with not the same sort of measure, units of measure, right? So so how do we sort of get any sense out of this 7.7 number, or 300 number, or 500 number, right? And that's when we start looking into correlation. Okay.